Welcome to you students to the class of mathematics, class 12. Okay, so today we are starting a very important topic and it comes under the section of calculus, and the name of the topic is continuity. Okay, so basically this word continuity comes from the word continuous. Now what do you mean by continuous? Continuous means something, whenever you are drawing it, you should be able to draw the diagram of that particular thing without lifting your pen. Okay, so that's your basic concept of continuous, isn't it? So let's try to understand what is the meaning of continuity in calculus. Okay, so for that we will consider this function and we will try to draw the graph of this function. Now here we have fx equals to 2 if x is greater than or equal to 0, and the value of fx will be equals to 1 if x is less than 0, or in other words whenever x is negative. Okay, so all of you know that we generally write a function fx as y, isn't it? So basically y is equals to fx here. So you see there are two values for the function, that is 2 and 1. So basically they are the values for your y. So that's why I have plotted the two values of y in the y axis, that is 1 and 2. Okay. Now if x is equal to 0, see in this case we see that x is equals to 0. So whenever x is 0, then the value of the function is how much? It is 2. So that's why here I have plotted the value of y by this dark circle whenever x is 0. Now what do you mean by this circle? This is open circle, isn't it? Now open circle means that this point is excluded. That means whenever x is 0, the value of y cannot be 1, but it has to be equal to 2. That's what is the meaning of this, isn't it? Okay, fine. Now let me take, see, just now we have taken the value of x to be 0, isn't it? Now we will take any positive value, okay, positive value of x. So this lies here, isn't it? The positive values of x lies this way. So whenever x is, for example, 1, the value of y is how much? If x is 1, then x is greater than or equal to 0. So that's why the value of y becomes 2. So my value of y lies somewhere over here whenever x is 1. If x is 2, then the value of y will be also 2, which is going to be lying somewhere over here. So in that case, for any value of x which is greater than 0, you will get a line like this. Okay. Now similarly, whenever x is less than 0, whenever x is less than 0, then the value of function is how much? 1. Yes. So that's why I have drawn this line. Now my question is, will I be able to draw this graph of this function fx equals to this one without lifting the pen? Your answer is no, because you draw from here to here without lifting the pen, but when you jump from here to here, you have to lift your pen, isn't it? Okay. So don't imagine that or don't think that I will go this way. This y-axis is just your imaginary line. Okay. So we cannot draw like this, draw this and go this way. Okay. So that's not allowed. So basically think that x-axis and y-axis, they do not exist. So in that case you will not be able to draw the diagram without lifting the pen. That means, in other words, I say that this function is not continuous. Okay. Now let's see few conditions which will tell you whether the function is continuous or not. For example, here we see that function is not continuous. So let's see the condition when the function is not going to be continuous. Okay, so you must be knowing about left hand limit, isn't it? So left hand limit means if x is going towards 0, see basically here we are finding the approximate value or limiting value at point 0, because the function is breaking at x equals to 0, isn't it? Okay, so that's why whenever x goes to 0 from left, okay, so from left, whenever x goes to this 0, Basically that particular x is less than 0, isn't it? So that's why the value of the function, if x is going to a 0 from left, will be equals to how much? 1. X is less than 0, x is going to a 0 from left means x is less than 0, then the value function is 1. So that's why your left hand limit will be equals to 1. Okay, and in the same way your right hand limit. So in this case x is going towards 0 from the positive side. Alright, so whenever x is going towards 0 from positive side, that particular x is always greater than 0, isn't it? And whenever x is greater than 0, the value of function becomes 2. So that's why your right hand limit turns out to be 2. Left hand limit is 1, right hand limit is 2. Clearly they are not equal, isn't it? So a very important thing that we can derive from this particular thing is the function will not be continuous if the left hand limit and right hand limit are not equal to each other. Okay, now this is one case. Let's understand other case now. For that we will consider this function. Now you see, whenever x is equal to 0, okay, whenever x is equal to 0, the value of function is 2. So that's why I have excluded 1, but I have plotted 2 here whenever the value of x is 0. Now x is not equals to 0 means either x has to be less than 0 or x has to be greater than 0. Okay, so for example, in this case, if I take x to be positive, that is greater than 0, again the value function is 1, isn't it? So that's why I have drawn a line parallel to x axis at a distance of 1 unit. Okay, now other cases, whenever x is less than 0, that time also my functional value is how much? It is 1. So that's why there's a line which is parallel to y axis at a distance of 1 unit. Okay, fine. Now again my question is same. Will I be able to draw this diagram without lifting the pen? Again your answer is no, because this point is lying outside this line, isn't it? And here there's a gap. Okay, there is a gap out here, so that's why you will not be able to draw this diagram without lifting your pen. That means this function is also not continuous. Okay, so in this case, let's see what happens with the left hand limit. Left hand limit means x is going towards 0 from left. So from here x is coming towards 0 and that particular x is always less than 0. So whenever x is less than 0, you know that the function will take the value to be 1. So that's why your left hand limit is 1 here. Similarly, right hand limit is also 1 because x is coming from right and going towards 0 and that particular x is greater than 0. So whenever x is greater than 0, the value of function goes to 1. So that's why your right hand limit is also 1. Okay, so here we see that both left hand limit and right hand limit are equal and they are equal to 1, isn't it? And still you said that this function is not continuous. See, in earlier case you saw left hand limit and right hand limit, if they are not equal, then the function is not continuous. But in this case we see that left hand limit and right hand limit, they are equal, but still the function is not continuous, isn't it? Okay, so in order to make this function to be continuous, let's see what can be done. For example, this is what? This is f of 0. The value of function at 0 is how much? 2. Okay, now if I shift this to this point, okay, so if I shift this point to this point, now in this case your f of 0 is how much? 1, isn't it? At 0 the value function is 1, isn't it? Now will this be a continuous function? Yes, because now you will be able to draw the diagram without lifting your pen. Okay, now see here carefully. In this case also we have got left hand limit and right hand limit, both are equal to 1. And here we see that the functional value is also 1. So basically what is happening here? we are seeing that the function becomes continuous if left hand limit and right hand limit both are equal. That's for obvious. And on top of that, it has to be equal to the function value, that is f of 0, and all of them are, see, all of them are equal to 1, isn't it? So that's why your definition for continuity of a function says a real valued function f is continuous at a point C in its domain if left hand limit is equals to right hand limit and they are going to be equal to the functional value. Okay. So in this example, I have taken the point C to be 0. Okay. We are checking the continuity at point 0, but in general we call that point to be point C, which comes from the domain of the function. Okay. So that's what is the definition of continuity of a function. And one more thing that you need to remember is, all of you know that whenever left hand limit and right hand limit are equal, both of them can be combined and written as this much. Okay. So you can either write this as your definition or you can write this as your definition. Okay. So you may pause the video and note down the important points.